Picture this. Your 210 prof was about to teach some kids about object-oriented programming. You open your lecture notes, about to start, when all of a sudden you realize you forgot diagrams for visual aid. You open up your laptop and start drawing, but alas, you have no hand-eye coordination on the trackpad.
I hate UML diagrams. What the heck?
Or perhaps you are a student at a Google Find Around on-site interview, and they ask, "Hello, I will be your Google interviewer today. First, how would you design a parking lot? And then, draw a UML diagram of every single class. Go." Introducing UML++, a DSL used to help generate custom UML diagrams, patent pending.
We wanted our language to be simple, easy, and intuitive to users, so we designed our initial grammar with that in mind. A sample program would be as follows. Start by declaring your components, which could be a class, interface, or an abstract class. Then you can add fields or methods, and you can specify the visibility, type of fields, or return type of the methods. Then you can specify the relationship between the classes. You could think of class diagrams as a graph where the classes are nodes and the relationship between them as edges. So we needed a graphing library. And thankfully we found one, so we don't have to reinvent the wheel. However, the library is not actively developed anymore and contained few critical bugs that we had to find fixes for. The class shown here is the UML builder that built on top of the aforementioned library.
Now that we've come up with our initial design, we quickly found a guinea pig to try our new language. We gave our user a task to design a UML class diagram for a zoo. This was the output he came out with. Looking at our user's output, we noticed a lot of duplication. To reduce the duplication, we created variables so users can use the variable instead of the full class name when declaring fields and relationships for that class. Additionally, we had to write one class declaration statement to declare one class, but this was quite repetitive if you had a lot of classes. We streamlined our language to allow for multiple classes to be declared in one declaration statement.
With our first user study completed, we redesigned and modified our grammar and built an ASD to visualize our program. We split the work into 4 equally big implementations: the class deck, attribute deck, relationship, and statement class. In our lexical analysis, we stored our classes into a set and hash mapped our attributes to class keys to practice security by checking class existence before adding attributes and before connecting relationships by name checking, with the statement class tying it all together. Lastly, with our output grammar, we used JGraphics to visualize our UML graphs beautifully and professionally, concluding our implementation work.
After going through several more iterations and reviews of our language, we were ready for our second round of user testing. At the start of our user testing, we can see that the user managed to learn the language pretty quickly through our given examples and was able to quickly figure out what was going on and completed our task without any difficulty and with minimal questions. The user found the syntax to be quite clear and commented on the simplicity of the commands. Also, the user was able to provide a valid input to our program to successfully run and produce the UML diagram shown.